Hello everyone, welcome to BYJU'S exam prep. I hope everybody is doing very well, guys. And tell me who has joined the session. So let's everybody join the session, and as you know, we have started this special series which is known as the Special 26 for all of you. In this particular series, we are discussing 26 topics from your particular GATE paper, the EC and electrical specifically. So we have already done a few classes based on this particular series. Rakesh sir, Sanjay sir has already taken a few classes. Now today's class I am going to take for the electrical students, in which we are going to discuss about the transformer, and not only discussion, we are going to solve the questions, because this is the time where you need to solve as many questions as you can, and that should be the exam oriented. That should not be happen that you are solving a question from the topics which are not relevant from the examination, or the topics which is not repeating that much in your examination. So in today's class we are going to discuss the question from the transformer topic, and we'll try to solve 6 to 7 questions in our this particular session. So tell me who has joined the session. Tell me, guys. Tell me who has joined the session. Let's everybody join the session. Also, guys, you have to share the session among your friends so that more and more students can join it and watch this particular class specifically. So let me introduce myself. My name is Shan Mudgal. I have a 7+ year of teaching experience, AmTech gold medalist from NIT Allahabad, 7 times GATE qualified, and these are my area of expertise. Now, before starting a session, let me tell you one very important news, that most of the students of ours has reached the UPSC ESC examination. As you can see, 5 aspirants are all India rank 10, 29 are under all India rank 50, and the 37 are under 100. So let's congratulate to each one of them, and hope next year there will be more students like you will be on our result. Okay, so what we are going to do, we are going to solve question based on a transformer on the topics that have been repeated multiple times in your previous year GATE exams. Okay, so this is the first question on your screen. This is the first question on your screen. Kindly read the question carefully and tell me how to solve this question. Okay, or also try to solve it. I will give you 1 or 2 minutes to solve this question, because as many questions that you can solve by yourself, that will be good. Understand, bachcho? This revision sessions, or I can say the practice sessions, in these sessions you have to solve the question by yourself. The particular answer is not important. You are getting a right answer or not. The important is, are you following the right path for solving a question? Are you solving this question through a right path or not? That is very, very important. If you know that you are on the right path, then you can solve the question easily. Okay, so read the question carefully and try to solve it. Today's question based on a transformers only. But there are students online. Tell me who has joined the session. Jaldi se batao. Let me see. Wait a sec. Okay, so कैसे होगा क्वेश्चन? हाय वीरा, कैसे होगा क्वेश्चन ये? Think about it. Let me read the question. The load shown in the figure absorbs 11 kilowatt at a power factor of 0.9 lagging. Assuming that transformer to be ideal, the value of the reactance X to improve the input power factor to unity. So they are asking what will be the value of reactance X so that input power factor is unity, whereas for the load we have given it absorbs 11 kilowatt power at a power factor of 0.9 lagging. So think about it, how you can solve this question. We have given a secondary voltage of 110 volt also. So whenever you are solving a question of transformer, or I can say machines, I will say, whenever you are solving a question from an electrical machine or from a power system, always remember you have to take reference. Either take voltage as reference or current as reference. We have clearly mentioned that we have a 110 volt at the secondary side, so why not we can take a reference of that particular voltage. If I am taking this particular reference, then the angle will be 0 here. Okay, and every voltage and current will be calculated based on this reference only. Okay, this is very, very important point that you need to understand. in every, I will say, AC circuits also, wherever you are solving a question from AC, always remember you should have take a reference there, either voltage or current. So let's solve this question carefully. So they have given that a particular load is absorbing 11 kilowatt power at a 0.9 lagging. So can I find out a current here? Now see very carefully one point. That dot convention. From here, the current is leaving. Let's suppose it is a secondary current. From here, the current is leaving IS. Now because the current is leaving from a dot, the current must enter into a dot also. Here, the current must enter into a dot. That is very, very important. On a transformer, if a current is leaving the dot, then on other side, it must enters the dot. Now, because of that, the dot represent the positive polarity. The dot represent the positive polarity. So we can mark the positive polarities like this. Yes or no? Do you know how to use the dot convention? Dot convention for a transformer is very, very important. Now let's solve it. Let's talk about IS. What will be the IS? That will be equal to power divided by Vs multiplied by cos phi. Okay. Now power given is 11 kilowatt. No problem. Source voltage is 110 and power factor is 0.9 lagging. 0.9 lagging. Remember, this is the magnitude of current. Remember, this is the magnitude of current. So by using a calculator, we can solve this. So we got 111 ampere. Okay. So what is the source current phasor? In a phasor quantity, it is equal to 1.111 angle minus cos inverse of 0.9, because it is clearly mentioned that we have a lagging load. It is clearly mentioned we have a lagging load. So what is the cos inverse of 0.9? It comes out to be minus 25.84 degree ampere. Yes or no? Okay. Now we have a source current here. We have a source current here. From there, I can find out the primary current. My fault. We have a secondary current here. From the secondary current, I can find out a primary current. Kaise? So primary current is equal to N2 by N1 multiplied by the secondary current. Now N2 by N1 is how much? 1 by 2. Is how much? 1 by 2. So 1 by 2, 11.11 angle minus 25.84 degree volt. Sorry, not volt, ampere. So here we can find out 2 5 10. Here. 5 angle minus 25.84 degree ampere. Yes or no? Any doubt here? Now, अब क्या होगा? सोच बताओ. Tell me guys what we have to do now. What we have to do now? Think about it. See very carefully. We have find out the current that is flowing here, which is, I can say, the primary current. We can also find out the voltage here. Let's suppose it is Vp, it is Vs. So I can also find out what is the voltage here. The phasor side. Remember, phasor quantity. 2 by 1 multiplied by 110 equal to 220 volt. Okay, angle 0 degree. So we have find out Vp also. Now understand one point. The question is you have to find out the reactance X so that power factor should be unity. So that power factor should be unity. What you can do, see very carefully. Let's suppose the current here is I1. Let's suppose the current flows here is I1 and the current flows here is I2. Let's suppose the current flows here is I2. Now understand this concept carefully. What is the IP here? If you apply the KCL, IP is equal to I1 plus I2. IP is equal to I1 plus I2. Now listen very carefully. You want a unity power factor from the source. So this I1 should have a real quantity only, and this I2 should have imaginary quantity only. Why it should have an imaginary quantity only? Because all the imaginary power is given by this reactance only. The source is not giving any power. The source is not giving any power. It means this reactance only provide the imaginary term. This particular I2 only provide the imaginary term. So here I can say what is I2? I2 is equal to imaginary term of IP. I2 is equal to imaginary term of IP. If I2 is equal to imaginary term of IP, then I1 will be a real quantity, and because of a real quantity, the power factor will be unity here. Understand this concept? Now, what is the imaginary of IP? IP is this one. The imaginary is 55.5 sine of 25.84. This is the imaginary term, that is equal to I2. So I2 comes out to be how much? 55.55 sine of 25.84. It comes out to be 50 ampere. Okay, now what is the reactance? Reactance is equal to V2 divided by I2. V2 divided by I2. So V2 is how much? V2 we have calculated is 220 volt. This is 50 ampere. So reactance comes out to be how much? 4.4. It is 4.4 ohms. It is 4.4 ohms. So I hope you understand this question. अच्छा question है. अच्छा question है. You have to use the concept of networks also. So again, what we have done, we have find out what is the current here, IP. We have find out this particular current. Now according to a question, the power factor should be unity. For that, I1 must be real. If I1 is real, then all the reactive power must be provided by I2. All the real reactive power must be provided by I2. So that's why I2 is equal to, sorry, there will be minus sign here. I2 is equal to minus imaginary times of IP. Achha, let's check one point here. Just one mistake here. This is actually I1 I2 plus IP. I1 I2 plus IP. Okay? So I2 is minus imaginary times of IP. Minus imaginary times of IP, then it will be equal to, what is the imaginary times of IP? Here you can see IP is this much, the imaginary part comes out to be this. Now we have a I2, we have a X. So if I have a I2, the voltage VP I have, then by using the Ohm's law I can find out the reactance, that is equal to 4.4 ohm. Okay, so I hope you like this question. And बच्चों जो live है बोलो ना, tell me कौन कौन live है, कौन कौन live देख रहा है? Okay, why all of you are so much quiet? Why all of you are so much quiet? Now again, try to solve this question. अच्छा question है. Question based on tertiary transformer. Question based on tertiary transformer. The question is, an ideal transformer has 3 windings, 200 turns, 100 turns, and 50 turns. Secondary feeds 5 ampere to purely resistive load, while a capacitive to tertiary take 20 ampere. Calculate the current in primary winding and its power factor. Okay. So according to a question, we have given this. This is primary. This is secondary. This is tertiary. We need to find out the primary current and its power factor. Think about it, how to solve this question. Simple hai. Just you have to solve this question very carefully, otherwise the question is simple. And this type of question has been asked in a GATE examination, also in your multiple different exams. So this topic of tertiary winding is important, bachcho. The question comes out will be very simple. No need to draw the phasor diagram. Just you need to understand one concept, which is a current balancing formula. If you remember the current balancing formula, then this particular question is easier to solve. Remember, the primary current, you have applied the voltage. So the flux, there will be a flux here. Now this flux is going to be revolve around the complete transformer, and there is no leakage, because nothing about leakage is mentioned in a question. If nothing about leakage is mentioned in a question, it means there is no leakage. So can I say N1 IP is equal to N2 IS plus N3 IT? This is the current balancing formula. Good afternoon, Sonia. This is the current balancing formula. So I can say N1 IP is equal to N2 IS plus N3 IT. Now understand one point carefully. They have said that a secondary winding, there is 100 turns. Secondary feeds 5 ampere to purely resistive load. So can I say the secondary current is equal to 5 angle 0? Next they are saying, while a capacitive on tertiary winding takes 20 ampere. So tertiary winding, capacitor leads the current. So I can say 20 angle 90 degree ampere. Now the question will be very much simple. Just put all the values here. What is N1? N1 is 200. So it will be 200 multiplied by IP is equal to 100 multiplied by 5 angle 0 plus N3 is how much? 50 tons. So it will be 50 multiplied by 20 angle 90. 50 multiplied by 20 angle 90. Yeah. So from here, IP is how much? Divide by 200. It comes out to be 2.5 angle 0. है ना? Divide by 200 to 002. It comes out to be 5 angle 90. If I'm not wrong, है ना? Let me check. It comes out to be 500. Now IP is equal to 2.5 plus J5. 2.5 plus J5. Now what is the magnitude of IP here? What is the magnitude of IP here? We can solve it using a calculator. We can solve it. It comes out to be 5.6 angle 63.43. 63.43 ampere. Okay? Now what they are asking? They are asking the calculate in primary current. So current in a primary winding is this one. Current in a primary winding is this one. Now they are asking its power factor. So we can find out the power factor. It is equal to cosine of 63.43. So how much you will get? Cosine of 63.43. So we will get 0.45. Approx 0.45. Yeah. Understood? Yes or no? And it will be leading. It will be leading. Because the power factor is positive, it will be leading. Okay, अच्छा question है. This type of question has been asked multiple times in your GATE, ESC and different AJE exams. So that is why it's a very, very good question. Also, the previous question was important. I hope you understand this one also. Now next one. Try karo. Try karo. Try this question carefully. A 50 Hz single phase transformer draw a short circuit current of 40 ampere at 0.35 power factor lag. When connected to 16 volt 50 Hz, what will be the power factor if it is energized from 16 volt 60 Hz source? Okay, read the question carefully and then give me the answer. So they are asking what will be the power factor if it is energized from 16 volt 60 Hz source. Think about it. And it is important. Draws a short circuit current of 40 ampere at 0.3 power factor lag. 0.35 sorry. Think about it. कैसे होगा क्वेश्चन? कैसे होगा क्वेश्चन? कैसे होगा क्वेश्चन? देखो, the machines questions are very simple. Yes, I'm saying it's simple, but it is simple for those who know how to think that how to think critically. Okay, there will be no straightforward question. आपके पास straightforward question नहीं दिए जाएंगे कि जाओ यहाँ पे आपको efficiency निकाल दो, power निकाल दो. The chances are very less. The question will be a straightforward. But the particular question that always come is always asked about the tricks that has been asking in previous exam also. That's why previous year question in case of machines are very, very important. I hope आप लोगों ने previous year question कर लिए होंगे. नहीं करे तो जल्दी से complete कर लो because the time is very, very less. Now, solve करें कैसे होगा? So they are saying if they are asking about a short circuit, so I can make a short circuit model of transformer like this. I can make a short circuit model of transformer like this, where R represent the total resistance, X represent the total reactance, and the supply initially here is 16 volt and 50 Hertz. 16 volt and 50 Hertz. Now they are saying the current of 40 ampere at 0.35 power factor lag. So from here, can I say what is the tan phi? Yeah, not tan phi. We can say what is the tan phi? Tan phi is equal to X by R. Simple. Think about it like a normal network circuit. Think about it like a normal network circuit. So tan phi is equal to X by R. This is going to be the tan phi here. Simple network circuit we have. Now what is phi? What is phi? Phi is cos inverse of 0.35. Phi is cos inverse of 0.35 because it is given that power factor is 0.35 lag. So let's solve this equation. Cos inverse of 0.35, 69.5, and the tan will get me 2.67. Okay. So from here, X by R comes out to be 2.67. This is going to be equation number 1. Any doubt how we get this particular point? Because we have a short circuit transformer. The model of a short circuit transformer can be like this, where R represent the total reactance. You can say refer to the primary side. X is the total reactance referred to a primary side. So from there, this is a simple network circuit. If we have a network circuit, can I find out what is 10 phi? It is equal to reactance part divided by the resistance part. Simple. Now, if the supply is changed, what is the impact that happen when supply is changed? Or I can say frequency. Supply frequency, because voltage is constant. Voltage is constant. When supply frequency is changed, so tell me what is the impact that we got. We got the reactance will be changed. The particular point is that the reactance will change. There will be no impact on resistance. There will be no impact on resistance. Madhu, are there any schedule for computer science? Beta, that will be announced after a few days. Okay. So when supply frequency is changed, the reactance will change. Now, how the reactance will change? We know reactance is directly proportional to frequency. So can I say x2 by x1 is equal to f2 by f1? Or simple, I can say x2 is equal to f2 by f1 multiplied by x1. This will be the reactance in our second case. Now what they're asking? They're asking question, what will be the power factor? So for that, again I can find out 10 phi. That 10 phi 2 will be equal to x2 by r2. Sorry, not r2. 10 phi 2 is equal to x2 by r, because the resistance does not impacted by frequency. The resistance does not impacted by frequency. So I can say 10 phi 2 is equal to f2 by f1 x1 divided by r. f2 by f1 x1 divided by r. Now see very carefully. x1 by r is 2.67. It is 2.67. f2 is how much? 60. So it is 60. f1 is 50. So from here I can find out 10 phi 2. Okay, let's solve it. So we got 3.2. We got 3.21. So what is phi 2? Phi 2 is tan inverse of 3.21. Phi 2 is tan inverse of 3.21. So it will give me 72.7 degree. Now finally we need to find out a power factor. So what is the power factor? Cos phi 2. So let's cos of 72.7. So how much we got? और बच्चों इस तरीके से अगर आप लोग चुप रहोगे लाइव होकर भी, तो how would I get to know that you are understanding a topic? ये हमें कैसे पता चलेगा that you are understanding a topic, है ना? So you can see the question is simple. We haven't used the voltage magnitude, or neither we have used the current magnitude. Okay, simple. We have solved this question with a perspective of a network theory. We have given a short circuit, so we have drawn the short circuit model. From there we can find out what is the power factor angle, and in that way if the frequency is changed, only reactance will change. The resistance will remain same. So if the reactance will change, the simple concept we have used and find out a question. Okay, next one. This is a good question. For the system shown in below figure, the phase relation of current I with respect to the voltage VAB. Phase relation with the current I with respect to the voltage VAB. Again, this is a question where the particular dot convention is very important. Very important. Okay, so try to solve this question. I know most of the people will give me the wrong answer, but let's see. Let's try it. I will give you 1 minute time. And with the ideal transformer, Sonia, which question you are asking? Previous one. That was simple, see na? In a previous question, what we have done, we have just draw the short circuit model of a transformer in which the R and X represent the total resistance and reactance. Now, just observe it like a network theory. So we have the circuit. Can we find out what is the 10 phi? 10 phi is reactance divided by R, means it's the previous. This one. Or Sonia, do one thing. I guess you have joined the session late. You watch this session from the starting after the class, and then if you got any doubt, you can ask me on my Telegram channel. Okay, next. Meanwhile, try to solve this question. But don't forget to watch the session from the starting. Okay, because the first question that we have solved is a very very beautiful and very very important question. So try करो इसको, try करो. For the system shown in above figure, the phase relation of current I with respect to the voltage VAB. Can anybody give the answer? Can anybody give the answer for this question? See, most of you can think about it कि sir inductor लगाए तो why not the answer should be lagging, है ना? That's one point that can come in your mind कि sir inductor लगाए तो why there should not be a lagging nature. Okay, that is also true कि okay inductor लगाए तो lagging होना चाहिए, inductor लगाए तो lagging होना चाहिए. Arun said B. Okay, but remember one thing, the lagging nature of inductor can only happen if it is supplying the current, if it is absorbing the current. अगर वो current को absorb कर रहा है then it will behave like lag. अगर वो current को भेज रहा है then it will behave like a lead. This point is very very important, and because of that you have to see the dot convention here. So let's see the dot convention. Always remember, whenever the dot is connected, whenever the dot is shown, that dot always represent plus. That dot always represent plus, and the next terminal will be minus. Okay, now if it is plus minus, so obviously this will also be the plus minus, because we are talking about a parallel circuit, we are talking about a parallel branch here. So if it is a plus minus, it is also plus minus. Now see the direction of current, see the direction of current I. The direction of current I is leaving from a plus terminal. If it is leaving from a plus terminal across the inductor, it means this inductor is supplying reactive power. This inductor is supplying the reactive power. This inductor will supply the reactive power. So whenever the inductor supplies the reactive power, always remember there should be a leading nature. There should be a leading nature of inductor. That is very very important. Now out of these four, only one, option B, has a leading nature. So option B is the right answer. Option B is the right answer. This is very very important point. Now to understand this point more clearly, let me tell you one concept. If you have an inductor like this, plus minus VL, if the current entering at positive terminal, then inductor voltage is equal to L DIL by dt. But if current is entering the negative terminal and leaving the positive terminal, then inductor voltage will be equal to minus L DIL by dt. Then it is equal to minus L DIL by dt, and because of this minus, we have a leading nature. This is very very important point to understand. In network theory also multiple time question has been asked on this point. In transformer, what they have shown, you have to provide the plus minus sign using the dot convention. That's why the dot convention part is important here. Okay, so the only answer can be leading because they have only one option of lead. Otherwise, if you want to find out angle, use this concept and find out the angle here, you will got the 90 degree. Understood? The same happen for a capacitor. The same happen for a capacitor. If you have a capacitor such that plus minus VC, the current is entering IC, then IC is equal to C dVC by dt. But if through a capacitor, current is leaving from plus terminal, it means it is delivering the current, then IC is equal to minus C dVC by dt. Okay, important है, याद रखना भूलना मत. ठीक है, important है, याद रखना भूलना मत. Next, now before going further, let me tell you that Rakesh sir is going to bring a wonderful session for you on 13 December on 7:30 p.m. In this day, he will discuss about the preparation of GATE 2025 with your college or job. Most of you students are in a third year, in a final year, and some are doing job and they are preparing for the GATE examination. You require the perfect time management. That perfect time management is going to discuss by Rakesh sir, so don't forget to join this session. Also, we are providing 90% off on our programs via scholarship test, so don't forget to register for this scholarship test. It's going to happen on 10th December. Okay, now next one. Next question. Important. This is also an important question. Okay, try to solve this one. Try to solve this one. Everybody tried. Important point. The equivalent circuit referred to low tension side of a 100 by 200 volt single phase transformer is shown. So this is the low tension side they have shown. The load impedance connected to high tension side of transformer is 400 plus J300. For primary voltage of 100 volt, compute these two: the secondary terminal voltage and primary current and power factor. This required a calculation. Arin, I'm waiting. Solve it. Everybody should try it. देखो बेटा, important है आप लोग try करो और सही path पे जाओ. आंसर का सही आना गलत आना that is a secondary thing. Primary thing कि आप जो solve करो उसका path सही होना चाहिए. ठीक है? So try करो, इसको solve करो, and then I will discuss how to solve this question. And transformer के question बेटा ऐसे ही आता है आपके पास कि there should be a refer to primary side, refer to secondary side. I'm talking about a single phase transformer. और single phase transformer से definitely you are going to get one question of 2 marks. Okay, that's why I have chosen this topic. आपको एक question 2 marks का मिलेगा ही मिलेगा, and also there is a chances that you will get one more question of 1 mark or 2 marks separately. But one question is final from a single phase transformer. 3 phase transformer, the particular thing is dicey. Sometimes they give you the question from a 3 phase, sometimes they skip from the gate exam. But single phase is very, very important. Okay. Now this circuit that you are observing right now, this circuit is referred to the primary side except what? Except the load impedance that they have connected. The load impedance they have connected is 400 plus J300. That is on a high tension side. Otherwise, the whole circuit is in primary side. So it means I need to refer this particular load also to a primary side. How to refer? Do you remember how to refer this particular thing? Simple. R1 is equal to 1 by turn ratio whole square R2. So here what we can do, we have 1 by 4 multiply by 1 by 4 multiply by how much? We have 400 plus J300. 400 plus J300. So it comes out to be 100 plus J 4 7 ja 78. We can solve it 75. 100 plus J75. 100 plus J75, we can do it. Simple now. We have referred to it a primary side. Now what they are saying, we have to compute the secondary terminal voltage. We have to compute the secondary terminal voltage. So think about it, how we can do it. For primary voltage of 100 volt, what will be the secondary terminal voltage? Can we find out? See, V1 is here. So this is also the V1. This is also the V1. The load is already connected here that we have shown to a primary side. The load is connected here. So can you find out a current? Can you find out a current? Or you can use the voltage division rule. Or you can use the voltage division rule. So what is going to be V2 dash? What is V2 dash? The secondary voltage referred to primary side. So it is V2 dash. Do one thing. The values is very large now. The values is very large. Do one thing. Instead of 400 plus J300 na, take it as a 4 plus J3. Take it as a 4 plus J3 because values are very large compared to the what is given here. So take it as a 4 plus J3. So if I take it as a 4 plus J3, then it comes out to be 1 and it comes out to be 0.75. Okay, just for the calculation purpose we have taken this. Now what is V2 dash? V2 dash is V1 multiply by 1 plus J 0.75 divided by 0. This is J 0.7 divided by 0.2 plus J 0.7 plus 1 plus J 0.75. है So V2 dash is equal to V1 is how much? V1 is given 100. V1 is given 100. So what we can do? I can take this voltage as a reference voltage. I can take this voltage as a reference voltage. So it comes out to be 100 angle 0 multiply. Now we have to use the calculator. है ना? Machines में, power system में, power electronics में, the calculator is must. So you will get 1.25 angle 36.86 divided by, here it comes out to be 1.2 plus 1.45. So here I will get 1.88, 50.39. It will be 50.39. So how much we get? 100 multiplied by 1.25. It comes out to be 66.48 angle minus 13.53 degree volt. ठीक है? But what is the asking in a question? They're asking the secondary terminal voltage, but we have find out that terminal voltage refer to the primary. Terminal voltage refer to a primary. So we have to again refer it to a secondary. It comes out to be V2 dash multiplied by 2 by 1 because the turn ratio is 1 by 2. है ना? So it comes out to be 66.48 angle minus 13.53 multiplied by 2. So it will be हाँ सही है. So 132.6 minus 13.53 volt. Okay, सिंपल है, सिंपल क्वेश्चन. सर साइंटिफिक कैलकुलेटर बहुत लंबा हो रहा है सर. बेटा देखो यहाँ पर तो मैंने वैल्यूज चूज करी, एक्चुअली मैंने बुक से ये क्वेश्चन पिक करें तो हाँ वहां से बड़ा होगा, लेकिन बेटा जो ये पर्टिकुलर वैल्यूज है ना, इसको ये मत सोचना कि ऐसे एग्जाम में नहीं आएगा, एग्जाम में नहीं आएगा. बट एग्जाम में ना ज्यादातर कुछ ना फैमिलियर वैल्यूज आती है. जैसे कि अगर मैं बात करूं, या तो यहाँ पे सिर्फ आपको रिएक्टेंस दे देंगे, रेसिस्टेंस हटा देंगे, या फिर दे विल गिव यू वैल्यूज लाइक दिस 4 + j3 2 + j1 which are a smaller value, है ना. Now this question if they come in exam, this question will be of 2 marks. तो 2 marks में अगर आप इतना टाइम लगा रहे हो तो उसमें कोई गलत बात नहीं है, ठीक है, उसमें कोई गलत बात नहीं है ना. तो इसलिए कैलकुलेशन इजी आएगी, कैलकुलेशन से आपको घबराना नहीं है. बिकॉज अगर आप देखोगे जब से साइंटिफिक कैलसी को इंट्रोड्यूस किया गया है फ्रॉम 2016 टिल नाउ, तो किसी ने भी बच्चों ने कभी भी उस बात के ऊपर कंप्लेन नहीं करी कि कैलकुलेशन लंबी है. हाँ, कंप्लेन इस बात पे हुई है कि क्वेश्चन लेंथी है, क्वेश्चन में बहुत सारे पार्ट थे, बट कभी भी कैलकुलेशन के ऊपर कंप्लेन नहीं हुई है ना. तो हमेशा ध्यान रखना कैलकुलेशन इजी आएगी बिकॉज दे वांट टू टेस्ट योर कॉन्सेप्ट्स नॉट द कैलकुलेशन. उसके लिए तो कैलकुलेटर है ही आपके पास, है ना. तो इसलिए उस चीज का घबराना मत कि कैलकुलेशन बहुत लंबी हो जाएगी एग्जाम में. Now we have to find out primary current and a power factor. We have to find out primary current and a power factor. ये कैसे find करें? ये कैसे find करें? This is the primary current IP. This is the current I can say I2. This is the current I1, which is actually divided in 2 parts. I can say this is the core current. This is the magnetizing current IM. So it means if I'm able to find out I2 and if I'm able to find out I1, then I can find out IP also. Remember, everything is in phasor quantity. So I can say I1 is equal to core component plus magnetizing component. Now what is IC? The voltage is V1 by 500. V1 is 100. So V1 by 500 and it will be angle 0 because of the resistance part. What is IM? V1 by 250 but the angle should be minus 90. V1 by 250 but the angle should be minus 90. क्यों? Because across the inductor current always lag behind. सर ये EC है डबल ई. अश्विनी बेटा इलेक्ट्रिकल मशीन किस डोमेन का पार्ट है? EC का डबल ई का? सोचिए बताओ, और आपको आंसर मिल जाएगा. देखो जैसे ही आपने ये सोच लिया वैसे ही आपको आंसर मिल गया, है ना. So if you solve this particular thing, what you will get? 100 divided by 250, so 0.2 plus minus 0.4 I. So it comes out to be 0.45 angle minus 63.43 degree ampere. So this we got I1, this we got I1. Now what is I2? What is I2? I2 is V1 divided by the total impedance. I2 is V1 divided by total impedance. So 100 divided by 100 angle 0 है, ठीक है. divide by 0.2, 0.7, 0.2 plus j 0.7 plus 1 plus j 0.75. okay, so let's solve it. एंड बच्चों सेशन को शेयर करो दोस्तों के साथ, काफी इंपॉर्टेंट सेशन है ये. ऑल्सो आफ्टर 2 days आई एम गोइंग टू ब्रिंग क्वेश्चन जस्ट लाइक दिस फॉर द डीसी मशीन ऑल्सो. सो उसको भी देखना मत भूलना, इंपॉर्टेंट सेशंस है. जैसे जैसे आपके एग्जाम पास में आ रहे हैं, दीज सेशंस विल हेल्प यू टू गेट रिवाइज योर कंप्लीट कॉन्सेप्ट्स, और आई कैन से द मोस्ट इंपॉर्टेंट कॉन्सेप्ट. सो 100 डिवाइड बाय 1.88, it comes out to be 53.19. okay, simple. So I2 is this much. Now we have to find out the primary current. Primary current is I1 plus I2. Primary current is equal to I1 plus I2. again कैलकुलेशन देख के घबराना नहीं है बेटा, कैलकुलेशन आपको इजी आती है एग्जाम में, ठीक है. राइट नाउ वी आर टॉकिंग अबाउट द कॉन्सेप्ट्स. एंगल माइनस 50.39, ओके. सो सॉल्व इट. कितना होगा बाकी बताओ, किसी को कोई भी डाउट हो पूछ लो. इफ एनीवन हैज एनी डाउट दे कैन आस्क. एंड आई होप आप लोगों की मशीन्स एंड कोर सब्जेक्ट्स जो है वो एक्चुअल में कंप्लीट हो गए होंगे. सो इट कम्स आउट टू बी 53.62. कैलकुलेशन में चेक कर लेना, 53.62 माइनस 50.498. आई गेस यहाँ पे कहीं कैलकुलेशन रॉन्ग है, मैं चेक कर लूँ. 50.498 माइनस 50.5 एम्पियर. ठीक है, सिंपल आ गया. हो गया क्वेश्चन. ठीक है, कॉन्सेप्ट इजी था. बस आपको क्या समझना था यहाँ पे कि कैसे आपको रेफर करना चाहिए. एक बार आपने रेफर कर लिया, द वोल्टेज यू हैव, यू नीड टू अप्लाई द ओम्स लॉ, नथिंग मोर देन दैट. ओके, नेक्स्ट क्वेश्चन. Read the question carefully and try to solve. The question is based on auto transformer and you can definitely expect one question from an auto transformer. Either 1 mark or 2 mark. Definitely you can expect question from a auto transformer. So a 200-120 kVA 2-winding transformer is to be employed as an auto transformer to supply a 100 volt circuit from a 300 volt source. Important, 100 volt circuit from a 300 volt source when tested as a 2-winding transformer at rated load, 0.9 power factor lagging and 0.95 efficiency, the kVA rating and efficiency of resulting auto transformer. Now if they ask you in exam only the kVA rating, then it will be of 1 mark question. If they ask you about efficiency, then it will be a 2 mark question. Okay, so we are going to solve both of these things in a single question, but in exam they will ask you separately. Or what they can do, they can give this question MSQ type, means multiple select question. For a multiple select question, there should be more than one options that may be correct. So in that case, you have to solve each and every option that is given. So we have given an auto transformer of 200 and 100 volt. So first we have a 2-winding transformer of 200 and 100. Now they are saying, or you can also draw like this. We have a transformer like this, 200 ratio 100. Okay? Or now they are saying that we have to supply a 100 volt circuit from a 300 volt source. So how you can connect an auto transformer? You can connect an auto transformer like this. This will give you 300 volt, and from here you can take it as a 100 volt. Okay, now you can do one thing. Here. This is A, this is B, this is C, this is D. This is a dot convention, this is a dot convention. This is 200, this is 100. Now to get a 300, you have to connect it into a additive polarity. So if you connect it in an additive polarity, it will be AB, it will be C comma D like this. So this will be an auto transformer connection. Now they are asking, what is the kVA rating of an auto transformer? So remember this thing, kVA rating of auto transformer is equal to kVA rating of two winding transformer divided by 1 minus turn ratio of auto transformer. 1 minus turn ratio of auto transformer, very important formula. So what is the turn ratio of auto transformer? It is equal to 300 divided by 100. It comes out to be 3. Why? Because they are saying that at primary side we are supplying a 300 volt and secondary side we are getting a 100. So what is the auto transformer kVA rating? It is equal to two winding transformer. Rating is 20 kVA. Rating is 20 kVA. So 20 divided by 1 minus 3, it comes out to be 30 kVA, I guess, you know. It comes out to be 30 kVA. 3 minus 1, 2, 10. It comes out to be a 30 kVA. So auto transformer has a kVA rating of 30 kVA. So first part we have solved. First part we have solved correctly. Now next they are asking what is the efficiency of a resulting auto transformer. Now always remember when we talk about efficiency, what is the basic formula of efficiency? The basic formula of efficiency is output power divided by output power plus losses. This is the basic formula of efficiency, output power divided by output power plus losses. Now when you are using a two winding transformer as an auto transformer, then the losses remain same. Whether it is a core loss, it's a copper loss, the losses remain same. So that's why if you know the losses in case of a single two winding transformer, that will be used in case of an auto transformer also. Okay, important concept hai, yaad rakhna. So for an two winding transformer, we have given efficiency is 0.95. Okay, so efficiency is 0.95. What is the output power? We have a 20 kVA, 0.9 power factor lagging. So 20 kVA multiplied by 0.9 power factor. Then again 20 multiplied by 0.9 plus losses. By solving this, I can find out losses here. By solving this, I can find out losses here. Hai na? So let's use the calculator. Okay, so we got 0.94 kilowatt. We got 0.947 kilowatt as a losses. You can also check my calculation. We got 0.947 kilowatt as a losses. Now we have to find out efficiency for auto transformer. So for an auto transformer, what is the output power? अच्छा, output power का formula कौन सा use किया मैंने? That is the S multiplied by power factor. Remember, important है. So auto transformer के लिए output power क्या होगी? Rating we have solved 30 kVA. So we have a 30 kVA multiply. The power factor has been changed according to a question. No, there is no change of a power factor. So we have to use 0.9. Okay, there is no change of a power factor. 0.9 divide by 30 multiply by 0.9 plus 0.947, which is the losses. तो बताओ कितना आंसर होगा? Solve करो. Simple है. So we got 0.966 or I can say 96.6%. That is the efficiency. And here you can note one point that auto transformer has more efficient and the rating is more as compared to the two winding transformer. But can you tell me what is the disadvantage of auto transformer? What is the disadvantage of auto transformer? Disadvantage is there is no isolation. There is no isolation here. And here you can see we have a isolation. So that's why the auto transformer cannot be used for a high rated loads. Next. Now before moving further, let me tell you one more information that we have launched the mega mock test, which is open for all of you guys. So you can just register for it, give the test and check where you stand among your fellow aspirants. It will help you to boost up your confidence and also guide you how to which particular subject you are not strong or किस subject में आप strong हो. So don't forget to register for it. It is going to live again from 16 December to 22 December. So don't forget about it. Okay, you can find this on our app, and the app you can find it in a description link. Okay, now this is again the question from an auto transformer. Read the question carefully. But for this question, I will give you this question in your homework, because there should be one question that you should do in homework. So in every class, I'm going to give you one question for the homework. Do this question in your homework and give the answer in comment section. Give the answer in comment section. And बच्चों, let me tell you that core subjects of electrical are very very important. ये आपको पहले से पता है, मुझे इस बात को बार बार कहने की जरूरत नहीं है. Core subjects are important that you already know. So from the electrical domain, I'm taking a core subjects: machine, power system, and the power electronics. So for a machine, we have a 3 classes. Today we have done the first class of a transformer. Next class is on 14th or 15th that you can check from a schedule, in which we'll discuss the DC motor, and in the next machine class we will discuss the induction synchronous. After that, there will be a 4 classes on power system and 4 classes on power electronics. So these course, when you revise these core subjects, you will complete at least 11 important topics from your gate examination. And from these 11 topics, definitely you are going to get 9 questions. And the range of question can be a 1 mark, 2 mark, but definitely you are going to take a 9 questions. That's why the particular series, which is known as a special 26 series, is planned. The 26 important topics from your exam. Okay, so don't forget to follow our classes. If you have any doubt, you can join my Telegram channel, ask your doubts there. Also, my particular classes schedule will be posted there. So bye guys, take care. Before signing out, let me tell you, you can download our app also, where the free classes is happening on a daily basis. With that particular free classes, you can also avail the particular option in which you can have a leaderboard. You can give the answers and your marks will be displayed according to that in a live class. Okay? So, and also, if you are from students who are going to prepare for the GATE 2025 and 26, you can also join our this English and Hindi batch, in which we are going to provide live class, recorded lecture, study material, practice quiz and mock test. So don't forget to kickstart your preparation. So bye guys, take care, see you in the next class, and don't forget to watch all of our classes of this particular series.